Welcome back, everybody, to another episode of Deeper into Maths. And today we'll be learning an episode that is application oriented based of mathematics, and it is quite useful in the actual real life world and not that much attached to any of the stranger and abstract concepts of the mathematics. So let us begin quickly. It won't take at all a time. So let us start with the mean. The mean is the average. I'll write it. And the formula for mean, it is denoted by x dash, is summation of xi from I equals to 1 till n upon summation, okay, we'll write it afterwards, upon n. And for grouped data, it is summation of fi xi I equal to 1 till n upon summation of fi, where then we can write summation of fi equal to n. Then I'll write this n as small n. And here also I equals to 1 till n. This is for grouped frequency. This is for group data, and this is for ungrouped data. Let's move on to the next concept. It is the median. So the median is defined as if the data is arranged in ascending or descending order, then the middle term is median. And now let us understand what a median is in individual series, that is not a grouped series. We can find it in case where I'll write it ungrouped data. In case of ungrouped data, the median can be expressed as if n is equal to odd, then the term is n plus 1 by 2 term, and if n is even, then n by 2 and n by 2 plus 1 term, th terms. So this is a very important thing to know. And now if the data is grouped data, and in such case what do we do? So the formula is 1 median equals to L plus H by F and N by 2 minus FC, where L is the lower limit. I have to write here group data continuous. Lower limit of median class, and then H is the higher limit of median class, and N is the total number of samples, and FC is the cumulative frequency, that is the sum of all the frequencies. Alright, it is summation of fi from I equals to 1 till n and then what is remaining? NHF, and F is the frequency of that particular median class. Okay, so this is an important formula, so I'll highlight this. And another thing that is important, that is what we wrote over here, this formula. This is also an important one. So let's move further and understand what a new term mode is. And this, the mode is basically the, if we write a grouped data in a grouped data, the sample with highest frequency. So for example, if I take 2 is repeated 3 times in a certain experiment and 3 is repeated 4 times, as and the same time 5 is repeated 6 times, and then 6 is repeated 2 times, 7 is repeated 0 times. So here in this case the 5 is called as the mode. 5 is the mode. That is because of this particular thing. And in a group data, the formula for mode is equal to L plus H into F1 minus F naught upon 2 times F1 minus F naught minus F2. Yes. This is the formula for mode. It is also another important formula in this aspect. So now let us understand a pretty basic relation that is important, that is mode equal to 3, 2, I'll write a minus, then here comes median and mean. How do I remember this? So that we see ME is common in both, the D is greater A. So alphabetically D is greater than A. So the value of D. So we write median first and then mean. This is a short trick you can use to avoid any type of confusion. Yes, this is also an important formula. This is also an important formula. This one is also an important one, and this also. And after this, we'll study the measures of dispersion. That is literally called as the scattering of the samples, that how much the samples are scattered, and there are various ways that we can use. So the first way, I'll write A, is the range, and to find the range, there's a formula for coefficient of range equal to range upon maximum into minimum. This is the formula again. You need to remember these formulas in statistics. The next one B is mean deviation. And mean deviation can be understood as the deviation of a particular sample value from its mean. And so we subtract the value of the sample from the mean of the total samples, and then we get the mean deviation. is equal to summation of mod of xi minus x bar upon n. N is the cumulative frequency and x bar is the mean, n is the cumulative frequency, or we can say total number. And this is an important formula once again, and questions are mostly asked from these type of things. The third is the quartile deviation. And now we can say that the word quartile is derived from division of quaternary, and quaternary means 4. So in that case the qi can be given as L plus h by f I n by 4 minus c, where I'll now write L is the lower limit of class whose cumulative frequency is more than I n by 4, then f is frequency, h is z's class width, that is upper limit minus lower limit, c is cumulative frequency of the class that precedes the class of cumulative frequency just more than I n by 4. And the thing to note is that if we put I equals to 2, then we get median. And coefficient of quartile deviation equal to q3 minus q1 upon q3 minus plus q1. Yes, I always get confused in the plus and the minus, but still yes. Okay, this is an important formula. Let us move further. That is the variance, and the variance is the variation of a particular data from a particular given data. So the sample value is deviated by how much from a particular given number that we assign. So variance is denoted by sigma square, and we'll understand why sigma square in a minute. It is equal to summation of xi the square upon n minus x bar the square. Yes, this is the formula upon n. And the standard deviation equal to root of variation. So accordingly, if anybody asks us about the standard deviation, then it is variation upon x bar. No, it is variation the squared, and coefficient of standard variation. So deviation is sigma upon mod x. This is another important formula. Sorry. And this is an important one. The coefficient of variation is equal to sigma upon x bar into 100. This is a very important formula, as you see. And now let us discuss combined variance. And combined variance has a formula. If there are two samples of size n1 with x1 bar and n2 with x2 bar, and their means as rho 1 and sigma 2, then the standard deviation sigma square is equal to 1 upon n1 plus n2 into n1 sigma square plus n2 sigma 2 square. Here is 1 1 2 2 plus n1 n2 upon n1 plus n2 x1 bar minus x2 bar the whole square. And this can also be written as n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square upon n1 plus n2. And now here d1 is equal to x1 bar minus x bar, and d2 is equal to x2 bar minus x bar, being the combined mean. And now the last thing is the combined mean. With the combined mean, and that is the combined mean x bar net can be written as summation of n of I x bar summation. And now here we cannot cut this and simply write more summation of x1 bar. That is totally wrong, because they are into product and then addition. So I'll write n1 x1 plus n2 x2 plus n3 x3 and so on upon n1 plus n2 plus n3 and so on. So we cannot write it just like this. So this is another important formula. And with that we complete the whole chapter. Thank you for watching, and we'll meet in the next video.